student. In this video, I want to go over solving equations. The objective is for student to use properties of equality and inverse operation to solve equations. Before we go over equation and the process, I want to give you some vocabulary words and an algebraic expression. What is an algebraic expression? It could be any statement like I go and buy 2 t-shirts, $30 each. That would be an algebraic expression. If you write it out, it's 2 times 30, and that's the 2 t-shirt times $30 each. Now, what is the difference between an algebraic expression and an equation? Equation has a prefix equal in front, so equal something equal to something, and that would be an equation. It's a statement with an equal sign in there. It's a scale, and that is often used. We have the many type of equation: linear equation, quadratic equation, radical equations, and trigonometric equation, polynomial equation, exponential equation. What we will start with today is the linear equations. So there must be an equal in the math statement to make it an equation. It just has an equal sign. That's pretty much it. We might say I bought 2 t-shirts and it cost me $60. So 2 times 30 equals 60. And that would make it an equation because I have now an equal sign in there. The whole point of algebra though is to find something that is an equation that look like 2t equals 60. We're looking for the t. Solving for the t is the process of algebra. And the process that we use is called undoing or the inverse operation, so that we can eliminate and get rid of everything except for the variable. In the end, that variable stands by itself, then it is solved. You always see a scale, and we use that to remind you that the equation, the equal sign in there, remember, is going to always be balanced. Anytime that you undo an operation on the left or on the right, you're always going to make sure that you do it to both sides of the equal sign. We always want to make sure that the equal sign are lined up, and we can always make sure that we box or circle the answers. And better yet, if you have a highlight your answers, and that will call your attention right to it when you need to double check. And when you make something look beautiful, you look back and you're so proud of yourself. You should. When you make something like that, you want to keep it forever. But if it's something that is very scratchy, you can barely read it, you probably want to toss it right away. Right after you finish with your work, or maybe even before then, you would lose it and you wouldn't care because it's so careless. The process that we use to solve the equation, you will hear it quite a bit, is the inverse operation. Can everyone say inverse? Very good. Inverse operation means just that we're doing the opposite. Like if we are adding, we will do the opposite and by subtracting. If the x is subtracting, then we are doing the opposite by adding it. And then if it's multiplying, the opposite or inverse is multiply, is divide. And then the opposite of dividing is multiplying. So that is called, yes, go ahead and say it one more time, please. Inverse operations, or undoing the operation that is with the x to solve for the x. Starting with number 1, we have x plus 3. So the inverse operation of addition is opposite, or inverse operation of adding is subtracting. Subtract a 3 from both sides. 3 minus 3, that would become 0. You may choose not to cross it out and just go ahead and write the simplification down here. Make sure though that your equal sign is going to be lined up, and subtract 3 from 8 on the right hand side, and we end up with 5. Again, before I start solving, and draw a river line. This is h minus 12, and that remind me to tell you is not always going to be variable x. It could be any variable a, b, c of the alphabet, z, x, y, anything that is missing from this problem. That's what we're looking for. And you might say, what's taking away 12 will be equals 6. And the what stand for the variable. However, we're going to do it in the algebraic way, because later on we need to do these steps to solve more complex problem. The operation involved is that 8 take away or subtract 12. What is the inverse of subtraction? We're doing the inverse or undoing the minus 12 by adding 12. And don't forget, you are going to do it to both sides. I pause to make the number 1 look perfect. And I try to type it in. Make sure that the answer is circled or box. Or if you have a highlighter, even better if you just highlight the answer really quickly so that we can double check it. It will draw our focus right onto the answer, just like that. Make a little line underneath that. The right side. Add 12 to 6. 3, notice, is negative x over 3 or negative x divided by 3. So what is the inverse or opposite of dividing? Yes, if you say multiplication, you're right. Multiplication is the opposite of divisions. Multiply both sides by the exact same number, and I want to get rid of the negative 3 so that x can be a positive x and it stay by itself. Now notice if I only multiply a positive 3 to both sides, what will happen is that the negative stay with the x. I get rid of the positive if I multiply by a positive 3. Multiply both sides by negative 3. The x is going to stay by itself on the left hand side, and I'm left with negative 3 times 27, which make a negative. 3 times 7 is 21, so write 1 whole 2. 3 times 2 is 6, 7, 8, so that's make negative 81. Okay, circle your answer or box your answer or highlight it if you have the highlighter. The number 4 have 4t. Now, anytime we have a number with a variable just like that, and we don't have anything in between, it's multiplication. Dot inside, it's multiply always. So 4 times t, what is the opposite or inverse operation of multiplication? Yes, it should be division. We are left with just t equal 4 going to 48. So 4 going to 4 one time, 4 going to 8 two times. T is equal to 12. Problem number 5, you will see that we have a parenthesis to eliminate first. Anytime you're looking at a problem and we have the order of operation to simplify, like P for parenthesis, we see it in there, we want to eliminate it or get rid of it first by distributing or multiplying the negative 3 in. So when I multiply the negative 3, I end up with negative 3 times x, which is negative 3x. Negative 3 times positive 4, and that make it negative 12. And I write the problem to the right of it, an arrow to the right, and write it on the right with the new equation for you without the parenthesis. Now we have negative 3x minus 12 equal 8. Do the inverse operation to get x by itself. It has negative 3, it has negative 12 along with the left side. Which one do we get rid of first? Or which one do we undo or do the inverse first? Well, the closest one will stay last. So it's like my closest friend, is the negative 3 multiplying x. I would undo that last. The negative 12 is a little bit farther away, minus 12. We will go ahead and undo that first. Add 12 to both sides. Adding 12 to both sides will get rid of the 12 on the left. The inverse of negative 3 multiply x. Now this is where a common mistake can happen. Students think that is subtracting 3 from x, so they might say add 3 to both sides. That is wrong. Remember that we always have a multiplication in between the 3 and the x when there's nothing in between the 3 and the x. So the inverse operation, or to undo this, you have to divide by negative 3. Only x is left. Negative 3 going to 20, 20 over negative 3. Or we can have it into a mixed number, and that would be 3 dividing into 26 times 3 is 18. We have 2 left. And it's always over the same denominator. The mixed number, if we change it, is another form that you can have for answers. We change the improper fraction into a mixed number, and those are the two answer forms that you might expect for this problem number 5. 20 over negative 3 or negative 6 2/3. puzzle